Dependency injection is a great way to reduce coupling, increase testability, and make applications easier to upgrade over time. With .NET Core, Microsoft built dependency injection into the base set of components. In this video, we're going to look at how to configure and use dependency injection in .NET 6. We'll look at the various types of scopes, why interfaces are important, how to update dependencies, and more. Now, if you don't know me, my name is Tim Corey, and it's my goal to make learning C# easier. I do this by providing videos here on YouTube multiple times per week, plus I have a weekly podcast. I also provide courses on C#, web development, and much more at IamTimCorey.com. The profits from those sales are what pays for the free content here on YouTube so that everyone can have a great education in C#, not just those who can afford it. Now, this video, as with most of my videos, I'll create some source code. If you want to copy that source code, use the link in the description. All right, let's go over to Visual Studio. We're going to create a new project, and this is the first place we need to start talking about where dependency injection is, because by default, it's in ASP.NET Core project. It's already configured, set up, and ready for you to use. In console apps, WinForm apps, and WPF apps and other desktop type apps, it's not set up by default. You have to actually bring in dependency injection special in order to get it to work. It is there and it's available for you to use. You just have to know how to configure it. If you want to know more about one of those platform types, leave a comment down below, or better yet, go to suggestions.iamtimcorey.com. Leave a suggestion there as to which one you want to see me demonstrate how to add dependency injection into. But for us, we're going to use an ASP.NET Core web project type. And for that, we're going to use Blazor Server. So let's give us a name. Let's call this dependency injection demo and dependency injection demo app. And we'll hit create. And .NET 6, no authentication, yes to HTTPS, no to enable Docker. And we don't want to check this box here. This is a newer box, just in case you haven't seen it yet. What it's for is if you really don't like the top level statements where we don't have the static void main method, we don't have the program.cs or program class, we just have the program.cs file with the information in it. If you don't like that and you want to see all the boilerplate stuff, you can check this box. Now, I prefer the new way of doing things, so I'll leave it unchecked. But just so you know, you could go back to the old way if you really wanted to. Let's hit create. Once this gets created, what we'll do is we'll take out the, let's take out the stuff that's kind of the boilerplate stuff. So we have this data folder here with weather forecast service. We're going to delete that. This is how you set up the template to get rid of the stuff that is just boilerplate. You can also delete the fetch data page and come down here, program.cs, and we're going to get rid of this line right here, line 10, where it says add singleton weather forecast service. We'll talk about what that even was in a minute, and get rid of the top using statement for the .data folder, which does not exist. Or .data, actually, it's a namespace. So we've gotten rid of the weather forecast. I prefer to do that. Now we're going to leave the counter page because why not? We have a second page. But we're just going to focus in on the index page, and that's really the only place we're going to spend any time. So we're going to talk about configuring our dependency injection. Now, if you're not familiar with dependency injection, what it does is it allows us to, instead of saying, create a new instance of a class whenever we want it, we can put it into dependency injection and just ask for an instance of that class. So let's go ahead and create a class and call it manually to see how we would use not dependency injection, but just use it kind of on our own. So let's create a class or a folder. And we'll call it just logic. This is our logic folder. Inside here, we're going to create a class, and we'll call this demo logic. And obviously, this is a demo. Now, I want to show you a trick that someone in the comments pointed out. I forget who it was, but really great trick. I prefer to have the file scope namespaces. Now you can use editor config and have them always created that way. But if you're in a hurry like I am, where you're going to create 1 or 2 classes, you can still use file scope namespaces by either going to quick actions refactoring and saying convert to file scope namespace, or, and this is the way that someone commenter pointed out, put a semicolon at the end. Takes care of it for you. I love that. That's great shortcuts right there. Okay, so we're going to create a class called demo logic. We're going to create 2 properties, value 1, value 2. Now, these are a bit different. We're going to say private set, like so, which means we need to have constructor, CTOR. And here we're going to say value 1 equals, and I'll say random dot shared next, and let's give it a range of 1 to 1001. If you're not familiar with random, what it does is it gives us a pseudo-random number. Now, I've said give me an integer between 1 and 1001. But note, the reason I said 1001 is because the top value is excluded, meaning we go up to the value right below the top number. So we include 1, but we don't include the top number. So this way we can go from 1 to 1000. There we go. And I'm going to copy this and paste it and say for value 2 as well. And this gives me 2 separate random numbers, 1 for value 1, 1 for value 2. So in this next, just make sure you get the next random number, not the same random number. Okay, I'm not going to seed the random value, all the rest. We don't need to do that. This is just a quick demo. So with this, whenever you instantiate this class, you're going to put a value in value 1 and a value in value 2. That's random. So every time you create a new instance, you'll get new values for value 1 and value 2. They won't be the same as the last values from the last instance you created. This will be important. So now you have this really crazy business logic, which of course it's not. It's just a good demo. Let's go over to the index page. On the index page, let's clean it up a little bit. We'll get rid of the survey prompt and that hello, welcome to your new app. And we'll leave the hello world there. We're going to say at code. In the code section, we're going to say private demo logic, which we need to have a using statement for this, which we can do by saying at using dependency injection demo dot logic. Now I can also, if I wanted to, I could put it in the imports.razor file, and that would apply to all files, but I just need to apply to this file, so that's a way to do that. Okay, and we're going to say, let's call it logic. We're going to say protected override uninitialized. We're not going to do anything async. We're just going to do uninitialized. And in here, I'm going to instantiate logic equals new. So when you initialize this page, we're going to get the value for logic. All right, so we're going to instantiate that 1 time. So this should give us a new instance in this, this variable every time you load this page. And pages don't stay in memory when you go away from them. So every time you come back to it, it'll have a new value. Let's see that in action by coming down here. Let's say h3. Inside here, we'll say value 1 colon at logic dot value 1. And we'll copy this and paste it down below. And yes, I'm using h3 just for the sizing purpose. This is not how you write good HTML. This is quick and dirty. This is just, I'm using the structure elements for styling, and that's not a good thing. If you want to actually use it correctly, you would put probably div with a class of h3. But we're just doing a quick and dirty form here. So let's launch this as it is. So we're not going to do anything else. We're just going to launch this page. And the first page that comes up is this index.razor page. So let's wait for that to load. Waiting. There we go. So our values are 917 and 180. If I go to counter and come back, now they're 948 and 588. Come back again, 914 and 488. 893 and 286. So they're different every single time I come to this page. That's because I'm creating a new instance every time I come to this page. Now, what are the drawbacks of doing this? This equals new. This is not dependency injection. This is just instantiating a class whenever you need it, which seems fine on this one page. But what if I have to do it in 10 different locations, 10 different pages? Well, that's fine. I can do it in 10 different locations, but now all those pages depend on demo logic. And you may say, okay, that's fine, but we're not declaring that they depend on demo logic anywhere centrally. So you may not know that buried in the code, 1, 2, 300 code lines down, there is an instance of demo logic. So you have to figure out where all these dependencies are. Because imagine if you wanted to change demo logic, maybe you wanted to change how it worked, but you need to know what depends on it first to make sure that you change it in all the spots. Well, if I add a better demologic.cs file, then I have to go to every different place where this was and change demo logic to better demo logic, and then change all of my other code as well. That's how dependencies create tight coupling. I'm now coupled to this specific demologic.cs. So let's make the coupling a little less by putting it into at least dependency injection. We'll get to the final way of doing this later, but for right now, we're just going to put it into dependency injection. How do we do that? Well, we come down here to program.cs, and notice right here, this is where we configure our services. Whenever you see the builder.services, this means dependency injection. Our services are, our service configuration is where we configure dependency injection. And notice we already have some things here. We have add razor pages, we have add server-side Blazor. So these two methods do more than just one thing. They actually add a whole bunch of services into our services. So what it says is, hey, we know that you're going to need a lot of dependencies to run Blazor server. No problem. We can add those in this one method call. Now we're going to add our own below this. So we're going to say, actually, let's add a using statement first. Using dependency injection demo dot logic, like so. And now I can say builder dot services dot add transient, and we're going to say in the angle brackets it is demo logic, like so. Okay, now we're going to talk about add transient in a minute, but for now, this has added demo logic to our services list, which means we can ask for it whenever we need a dependency instead of newing up a dependency or instantiating a dependency like we are here. So let's do that here. Now, normally what we do is we would just ask for it in the constructor. But because this is Blazor server, it's a bit different. We say at inject. And we can say, I want a demo logic instance. And let's call it logic. Now, I already have down here this. Well, we don't need to do that. And we don't need to do this either, the instantiation. We just need to ask for logic. Then we can start using it right here. Because when we ask for it, what's going to happen is it's going to go to our services and say, hey, services, do you have a demo logic class? And it's going to say, yes, I do. Here is an instance of that demo logic. It's going to instantiate it for us, which this instantiation right here, that's handled by dependency injection. So we're just going to get an instance of demo logic. So let's run this. We've commented out all this code. Okay, we only have inject demo logic. That's it. Let's run this again and see if anything has changed. All right, we have 254, 849. So we are getting an instance. Let's see if it changes. Yep, 258, 806, 82, 545. We can do this all day long. And we'll get two different values, or different values every single time. So we now know we have dependency injection working, and that's really all it takes to get dependency injection to work. We just put it into, we put our instance, our class type into the services, and then we ask for it. That's it. Now, let's talk about transient. Because I said, just do this. And I like to explain why. So let's talk about transient. When you add a dependency into dependency injection, you have three different options when it comes to Microsoft's built-in dependency injection, which is what we're using. So we have add transient. What that means is every time you ask for the item, so in this case, demo logic, every time you ask for it, you'll get a new instance. So every time we say inject demo logic, we're going to get a new instance in logic. So every time you come to the page, we get a new instance. That's kind of the default, the standard of how the most cases for dependency injection are used is we use transient. That's the most common because usually you want a new instance every single time. Now, there are other ways of doing this. Let's say instead of add transient, we're going to add singleton. Now, if you're not familiar, what a singleton is it is an instance of a class that gets the same instance every single time. So when you instantiate a class, usually you create a new instance every time. Well, with a singleton, you create an instance once and then you use that for an entire application. Everybody uses that. So without writing any code, that's usually what happens. We have to write special code in our class to make it a singleton. But with dependency injection, we don't have to do that. We don't have to write any special code. We just have to say, I want it to be a singleton instead of transient. So let's see what this does differently. Remember I said it's going to you create one instance and then use it repeatedly. So we have 154, 338. Go to counter and come back, 154, 338. 154, 338. As many times as we want. In fact, if we take this URL and we go to a new page and paste it in, 154, 338. So if you were to somehow be on my network and could access my local host, you would get the same value, 154, 338, every single time. So we've created one instance and everybody on the web server uses that same instance. So it doesn't matter if you're across the globe, you'll get the same instance as everybody else. Now, I do want to pause right here to talk about the dangers of this. The singleton design pattern is one that is overused. It is something that people often see and say, great, this is awesome. I can share code among other instances. I can share code among guests. Well, yeah, you can, but that can be a problem because then if you write any data, so if I write data to anywhere here, well, then everyone else has access to that same data and they can change it. So usually you don't want to do that with anything where the user can write data or make changes. So it's usually for like shared configuration. So maybe if you look up information, everyone can have access to that same information, maybe, but even then be very careful because let's talk about connection strings. Well, you can say, well, I'll get a singleton of that because I don't need to keep looking up the same value over and over again. And it's more efficient to have one instance of this class rather than multiple. Well, yes, it is, but what if different people have different connection strings? Or same thing with passwords or anything else. Be very careful that you don't overuse this. The other thing is when I use transient, that transient went away when I came to the counter page, which means garbage collection can collect it and it can go away. With singletons, they are in memory for the life of the web server. So as long as the web server keeps this system running, those singletons are running as well. That memory is constantly in use. So that can be problematic too, because you've got stuff in memory that's lasting forever. It's a lot of stuff that can permanently clog your memory up. So there is a balance here. Be careful not to overuse singletons. But this is how you very easily create a singleton using dependency injection. The coolest part here, I want to make sure I point this out, is that we didn't have to do anything special to change this from transient to singleton. So if you're using demo logic and then realize, hey, wait, we don't need to have all these instances. We could use this as a singleton. I don't have to change index.razor or any other page or file that depends on demo logic. I just need to come here to one spot and change this from transient to singleton. I'm done. That's part of the benefit of dependency injection is you have centralized your dependencies and made sure you have the dependencies done once, not multiple times. So you can say, hey, you know what? We're going to make demo logic a singleton now. Now, there is another benefit here we haven't really talked about, and that is some people look at classes and say, hey, you know what? That data is not changing very often. Maybe I should make that static, a static class instead of a singleton or instead of an instantiated class. There can be reasons to use a static class. However, more likely that's going to be a bad thing. Okay, so you have to be very careful. It's a very small use case to create a static class. Part of the problem with a static class is you can't implement an interface because you can't instantiate it. You also can't inherit from other classes and use the instantiated parts of those inherited classes. So it really limits you to just that one class where it's kind of limited. But with a regular class that can be instantiated, you can have the same functionality in a singleton as a static class, but yeah, you can instantiate it. You can create an interface and have it implement that interface. You can inherit from other classes. There's a lot of things you can do because it's a full class that's instantiated or instantiatable. So really, if you're on the fence between a singleton and static class, more likely you probably want to think about a regular class instance that you then put in a dependency injection as a singleton. Okay, so we've got singleton, which is one instance for everybody, and we have transient, which is a new instance every time you ask. But there is a middle ground, and that is add scoped. Now, what add scoped does is it is a singleton per person. So let's see this in action so it makes a little more sense. So we'll launch our web server, and I have 818 and 774. Still 818 and 774. Still. Let's copy the URL. Go there again. 199, 198. That's interesting. So we come back over here. It's still 818 and 774, but over here, go off, come back on. It's still 199 and 198. So each tab, which is really a different instance of this Blazor server website, each instance of this website has its own copy of a singleton. So it's only available to this tab, this version of a site. This version of the site has a different instance. So there's two instances right now, one for each of these, but we're not going to create more unless we add more tabs. So if I keep coming back, it's still a singleton to this particular tab, but it's not available to any other tab, which means that when I close a tab down, let's close this one down, and I open a new tab back up, I now have a new copy. This copy is still here. So this allows me to kind of release some of those resources from the web server when the connection to that particular client is no longer in use. So it's not keeping one instance forever in memory like the singleton is, but it is keeping one instance per instance of me talking to the web server, which means that I can load something once per user, and then they have just that user has access to it, which means that if we're talking about connection strengths or anything else where it might be user specific, well, that'll be specific to them. We don't have to keep loading it over and over again because it's in memory once. And we just keep accessing it. So this is kind of that nice middle ground when, especially in a web server, where we have the ability to see, okay, these are different connections to it. So scoped is kind of that middle ground where we have one instance per, just think of it as per connection to the server. So each tab is its own connection to the server. If I went to Firefox, it'd be a different connection. If I went to a different computer and accessed it, that'd be a different connection. So this allows us to have that singleton-like feel, but again, be more specific or more localized to where that's available. So that's the three different types of service types we can use. So there's transient, which is the most common. That's a new instance every time you ask for it, which is what we're used to. I mean, that's what we're doing here. That's a new instance. And we just ask for it over and over again. Every time I say new, that's a new instance. So we're used to that, and that's the most common. But we can also do scoped, which is per connection or per user. And then we can do a singleton. Now, I will point out that if you are asking for scoped, but you're on a desktop client, then it's basically a singleton because there's only one client. It's that computer. And really, at that point, there's no way of differentiating multiple people because multiple people will have different instances of the application open, which will be different singletons anyway. So just note this is more for the web where you have one website running but multiple users, as opposed to the desktop where each user gets a full instance of the application anyway. So just note that. Okay, so we have add scoped, add singleton, and add transient. Now, that's the three different types. What we haven't talked about yet is really the common way of adding things to dependency injection, and that's through an interface. So let's go over here at demo logic. I'm going to say, right click on here and say quick actions refactoring, extract an interface. And this interface is just going to have those two values. I'll hit OK. And now it's implementing the iDemoLogic interface, which just has two properties with just getters, because actually that's all the interface sees. Let's put our semicolon here. That's all the interface sees is just the get, because the interface is not dealing privates. So anything public, which is just a get. All right. And it doesn't know about constructors either. Okay. So let's use an interface, this iDemoLogic, instead of the actual hard-coded demo logic. Over here, we can say iDemoLogic, like so. So there's our interface and our implementation. So what we're saying is when you ask for an iDemoLogic, give them demo logic. All right. So now we come over here, our index.razor page. We can just ask for iDemoLogic, ask for the interface, and we'll get, of course, logic. Let's run this and make sure it works as it is. There we go. Our two values, still the same because we're still in scoped mode. So there's our different values. And they keep them. Okay, so that's how you use interfaces. Now you may say, well, Tim, why do we ever use an interface? It seems like it's just an extra piece of fluff we don't really need. And I would encourage you to not think that way. I would encourage you to always use an interface with your dependency injection. One of the reasons why is because it's very easy then to remove dependencies when we're doing unit testing. Because again, when we look at here, it's saying right up front, this is what I depend on. But a unit test doesn't want to test all your dependencies. It just wants to test the actual code, which of course in our case is nothing. But when we test this, we could send a different interface, a mocked interface, instead of the actual demo logic instance to logic. That way we can control what the values are. Now, another thing you can do is let's go to our demo logic and we're going to copy this logic for now. I'm going to create a new class. I'm going to call it better demo logic. We're going to put our semicolon here. I'm going to paste in this same code. I have to change the constructor. But instead of random numbers, I'm going to say the first value is 25 and the next value is 50. All right. Now, is this better logic? No, not really. But this is what I'm going to put in. Okay. Better logic. Now, let's implement the iDemoLogic interface, which just those two properties, we're good to go. So let's say I wanted to replace everywhere I have this logic right here with better demo logic. Well, with dependency injection, I don't have to change any of the places where I have a dependency. Instead, I come over here to program.cs. Let's change it to add transient. That's what it should be normally. But instead of saying iDemoLogic gives you demo logic, it's going to say better demo logic. With one change, I now change my entire application. So I know we're only using it in one place. But what if I was using it in 100 places? Well, I change it in this one spot and we're done. The upgrade is complete. Let's run this and see the difference. 25, 50. Every time. Now, yeah, that wasn't great. And I might say, oh, you know what? That upgrade didn't go well. The better demo logic didn't work the way I expected it to. Let's go back to demo logic. Done. Let's run it again. Implemented. Works. Okay, that's how easy it is to change your dependencies around. Now, you may say, yeah, but Tim, how often do we gotta do that? Let me show you in a real life instance that you will probably use in the future. So let's implement logging. Now you may say, well, Tim, this is about dependency injection, not logging. Yes, you're right, it is. And so we're not gonna go deep into logging. I have a whole video on YouTube on logging. I also have more content in my courses on logging, but let's not go too deep into it. We're going to first talk about where logging is. Well, that comes from right here, Create Builder. This implements logging as well as sets up your dependency injection container, and it sets up your configuration for talking to app-settings.json. I have a whole course on that. But we're just going to use the basics of logging. So let's go over to our index page, and I'm going to say inject iLogger of type index. Call it logger. So this is already in dependency injection. So this allows us to log any message we want. Now, I give the type of index because this is the index class, and this allows logger to have more information about the class information it's logging from. But let's come down here on our uninitialized, and we're going to say logger.log information, and we'll say displaying values of value 1 and value 2. And then let's go on a new line here. where I say logic dot value 1 and logic dot value 2. Now, semicolon at the end, you may be looking at this and saying, Tim, you forgot something. You forgot the dollar sign at the beginning here, that string interpolation. And no, I didn't. And this is where, if you have not really dug into how logging works in .NET Core, you really need to. Because this is how we can do structured logging. So what we've got here is I just have a string, but then I have these curly braces, which normally we put a dollar sign in front, and now that would be an actual value. But notice it's giving me a red squiggly. These values don't exist because they're actually logic.value1, not just value 1. But I've put it in curly braces, and so what happens is that the log information, again, log error, log critical, these all work the same way. When I have curly braces, it looks at the very first one and says, okay, that value must be right after the comma. So that value right here, the one in the first position. So this right here goes to here, which I could call as anything I want. Still works, okay? Because it just corresponds to the first position. And this one corresponds to the second position. Now, why do I call it value 1? Because when our logger stores this information, it's not going to just store just the string unless that's all it can do. If it can only store a string like our default logger does in .NET, then it will just store a string. So it's just going to store the string where this right here gets replaced with the value of this. And this right here gets replaced with the value of this. However, when you have a structured logger, it's going to store this string, but it's also going to store this value right here separately in a separate column as the name value 1. And it's going to store the name value 2 with the actual value of this in a separate column. That way, when you do querying, you can query your logs based upon what value 1 is, not try to parse it out of a string, which parsing out of a string is a mess. So having the value in a separate column makes it much, much easier to do querying on your logs to get relevant information. So please, please, please do not use string interpolation when you're doing logging. Do not put the dollar sign first. Do it this way instead. The dollar sign will force everything to be just a static string, which means you won't have this additional information for your structured logger. Okay, that's a bit of a soapbox, but that kind of explains why I'm doing it that way. So I've got logging involved. Now, as you might imagine, we'll put logging throughout our entire application. So there will be, in a small application, you might have 1,000 different places where you are writing logging. So when you talk about a big application, you might have hundreds of thousands of places where you have logging information. Now, we're asking for this from dependency injection, and notice we're asking for an iLogger, an interface. Let's see where this shows up in our normal app. Okay, so since I'm using Kestrel, I get this nice little window over here. And notice that we have these two lines here that say that displaying values of 996 and 851, which happen to correspond to 996 and 851. Now you may notice, actually, Tim, you have two different places. Yes, I do. Why do I have two different places? Why do I have it running twice? Well, that's because of how Blazor Server works. And some people say, well, I need to turn this off. Now, I encourage you, don't. So what happens with Blazor Server, this is another little aside here, is Blazor Server actually renders on the server. And then it downloads the client so you see an actual value on the screen when you're first looking at it. But then it renders a second time to wire up things to be actually interactive. So that's why it renders the page twice. Once to give the user something to see very quickly, and a second time to behind the scenes wire things up and get things ready to go for interactivity. Now, yes, you can turn it off so you only have client-side rendering, in which case it's going to have, the page is going to be kind of blank at first until your page downloads and then renders. That might be what you have to do, but the better option is usually to just have it rendered twice. It's okay. It actually makes your client experience better, which is the point. But that being set aside, we've seen now we have our logging. Now, this window right here is because of Kestrel. When you use the IS Express, you won't see this, but this gives us a whole bunch of logging information. Notice this is all logging information. So it comes from Microsoft, but in here we have from dependency injection demo.pages.index, we have our logging information. So that's great, but why am I showing you information about logging? Well, let's close this out and let's think for a minute about what if I wanted to add a different logger. Maybe I'm tired of the basic logger that comes with normal dependency injection and normal ASP.NET Core site. What if I want to change that out for one that's actually more useful? Because the default one logs to the debug window, the console, and that's just about it. It's not really useful. So maybe I've already injected it everywhere and I go, oh no, I got to replace the logger with a real one. Not a problem. So let's go out and get a real one. Let's go to dependencies, right click, say manage NuGet packages. Let's look for Serolog.ASP.NET Core. I love Serolog. It's a structured logger. Let's install it. I have a video on this as well. This I cover Serolog and Seek, which allows you to store the data and then also have a web page that gives you a really great way of looking at your logs and actually reading what's going on. I would encourage you, and this is another little side, I would encourage you, if you log information, use it. Because if you don't use it, then get rid of it. You're just storing information pointlessly. And really you're making your life miserable because you're hiding the real messages you want to see with all the fluff of things you don't want to see. So use it correctly, use these levels correctly as well. So normally I don't log at the information level. I normally log at the warning level or higher. And then I have information messages in my application so that I can change my app settings.json when I'm running in production to turn on more logging if something weird is going on. Now, one more, and this is not about logging, but I want to make sure that we're clear here. One more thing that trips people up is, yes, you can change your logging level in app settings.json. People do that and say, Tim, it didn't work. Well, yes, it didn't work because you're in development mode. And there's a little hidden thing underneath app settings.json called app settings.development.json, which also has logging information. So you can either just delete this and work off of app settings.json, or just know you can change this here for logging locally, and then you can change app settings.json for logging in your other environments. So just know there's two different places, and app settings.development.json overrides app settings.json. Okay, and I have a whole course about that because just app settings.json, tons of great stuff in there. I would encourage you, learn that. It's really great stuff. Okay, so now I've created that NuGet package. I've added that one NuGet package. Let's actually use it. So back in program.cs where we configure everything, guess what? We're going to come down here under the services. This is not a service, but we're going to say builder.host.use Serolog, which we have to control dot. Actually, it's not going to work. We just do using Serolog at the top. Now it's going to configure. Okay. Open parentheses twice and say context and config. And then outside the parentheses, put an arrow and curly braces. Then put your semicolon at the end of all of that. Come back inside, and we're going to say config.write to console. That's it. Okay, that's the basics of configuring a Serolog. We're going to use the same console, but we've just said don't use the default logger from ASP.NET Core. Instead, use Serolog. Now, notice I did not change anything about my index.razor page. It still has ilogger, index, logger. It still has the message. Everything is still the same. I only changed in here to say this overrides the default logger with Serolog instead. Let's run this. Okay, nothing else has changed. Okay, we're getting values. Let's open up our window here. Looks a lot different, doesn't it? So a lot more color because it uses things differently. And then notice down here, I went to that page twice. And the first one was 618 and 740. The next time was 326 and 484, which is the current one. And notice they're a different color. That's because of the fact that, again, Serolog is a structured logger. It knows these are separate values. Now for the console, it just prints out the data. But if I were to store that in another medium, for example, in Seek or in SQL or in a number of other different syncs, it can actually capture those as separate values because it knows they're separate values. So now we have logging set up in a way that is no longer about the default logger, it's about Serolog. And yet I didn't change anything about my application. I didn't change anything about iLogger. But what I did was instead of using the Microsoft implementation of the logger, I used Serolog's implementation of a logger. So it's the equivalent of me coming up here to this add transient and saying, instead of demo logic, we're going to do better demo logic. That's the equivalent of what we just did with the loggers. And because I changed it in one spot, it changed for my entire application. So that's one of the benefits of using dependency injection. Now, sometimes people ask, well, what's the difference? Because I could have said equals new right here, as opposed to asking for it up here. It seems like it's a wash. It's the same thing. The only difference is I'm adding all this work up here. And people say it's all this work to add all of my dependencies in one spot. Well, here's the deal. By, first of all, putting all your dependencies in one spot, you are consciously thinking through all the dependencies of your application. And then you have a centralized place where you can go and look to see everything your application depends on. That's a really good thing because it starts to make you think. If you have 500 dependencies, you might want to think about, can we deal with less dependencies? Because our application is pretty dependent on a lot of stuff. But even if not, you've now got a place where you can say, here's everything we depend on. And then in your application files, you right up front say, I depend on this, and I depend on that. So you know exactly what they depend on. Instead of buried down here, you catch, oh, whoa, they depend on demo logic. Okay, so that is a real perk. It also makes you think through at the very beginning, what do you really depend on for every class? If that, again, that list gets too long, maybe it's time, that's your indication that, hey, we need to think through this because we've got a lot of dependencies here as well. But we also have this nice loose coupling like this, where, and actually this too, where we can change what we're connected to. Instead of being directly connected to demo logic, we're connected to an iDemo logic, so we can swap out what our coupling is, whether it's the demo logic or better demo logic or whatever. Same thing with our logging. Instead of being connected to just Microsoft Logger, we're connected to an iLogger, so we can swap out Microsoft for Serolog or for Log4net or for nlog or whatever logging tool you want to create or use from the internet. So this allows for this nice decoupled or at least loosely coupled application structure. Now, one question I often get when I do a talk on dependency injection is people ask, yes, Tim, but what if I have two different things that both implement the same interface? How do I get those into dependency injection? And There's a couple different answers. I'm going to show you, this is what they're asking about. They want to do this. Okay? That's the pretty common ask from people, is they want to put two different class instances under the same interface in dependency injection. I'm going to ask you a question. I want you to think through your answer here. Over here, let's just say that this does work. We can do this. Over here, when I ask for demo logic, which instance is going in here? Think through it as a compiler, not as the user who knows the answer. Think through it as the compiler. Which instance do you put in here? Do you put demo logic or better demo logic? How would you know and why? Okay, and the answer is you wouldn't know. The system doesn't know which one to give because they're both the same. So what's going to happen is it's going to give you better demo logic because it's the last one added. So that's probably not ideal. So you may say, well, I want demo logic sometimes and better demo logic other times. All right. So how do I deal with that? Well, that's when you might either create a different interface for both. So demo logic and better demo logic. That might work. Or you might probably not, but you might put just the actual class name in there and ask for the class name. But again, then you're tightly coupled to those classes. Or you can leave both of these in and ask for an array, in which case you get both of these and then you can figure out which one you wanted. But just be careful because that gets really messy then you got hard-coded places where you say, well, I want the type of demo logic, but then you're now tightly coupled to demo logic in that place. It's usually ugly. Usually, this is a code smell because what you're doing here is you're saying, I have two different classes that do two different things, and I want them to have the same interface, which, yes, they can have that, but then you probably shouldn't be using that interface in your dependency injection because you have to be able to tell your class, this is the one I want. So there are ways of getting around it. Again, I have a full course on the .NET Core dependency injection that goes into how to do that and how to differentiate the two and how to ask for both and so on. But I encourage you to think through, maybe this is not the right interface. Maybe use a different interface so you can differentiate the two. Even if that interface just implements the demo logic interface, but it's called better demo logic interface, just so that you can then ask for that when asking for better demo logic. So just note that by and large, you only have one implementation at a time for a given interface. It's only in special cases where you might have multiple, if you really want multiple to come through. So that's something to think through. Again, I cover more of that in the course. You really need to go into that. And that's kind of like an edge case because in general, you'd only have one implementation per interface currently active in dependency injection. So that's how to use dependency injection in .NET Core. Now, or .NET Core or .NET 5+, which is still .NET Core, but we drop the core name. So with this is built right into ASP.NET Core. So if you're using MVC or Razor Pages or API or Blazor Server or Blazor WebAssembly, this is built right in. So you have this automatically. For things like WPF and WinForms and console apps, it's available to you, but it's not set up and configured by default. Same thing with Azure Functions. So you can enable those, and let me know, again, on the suggestion site if you want to see a specific one implemented. But this is for all of our web project types just out of the box. It's just there. We can just start using it because Microsoft said, hey, we need this. So let's go ahead and implement that and allow you to extend it. Also note that just like everything else, we can, instead of using Microsoft dependency injection, we can actually use a third-party dependency injection like AutoFac. We can replace Microsoft's dependency injection with a third party and still use all of our setup. So lots of cool stuff there that we can do. if we want to grow beyond what Microsoft has provided, it's provided a really good tool for probably about 90 to 95% of all cases. It's just those more advanced and edge case things where you might have to bring in a third-party project, or if you just like how the third parties do it, then by all means use those instead. So this is how you use dependency injection. That's how to do the various things like scoped versus singleton versus transient, how to do things like ask for it in Blazor server, as opposed to, if you're in a class like this, you just put in the constructor and say, I want an I demo logic, and that'll give you an instance of it through dependency injection. One question that sometimes comes up is, well, what if this class depend on, well, here's a good one, iLogger. Demo logic. Let's call it logger. I'll do a control dot here to create and assign the field underscore logger. Now I can use this logger wherever we want in this class. But notice that now this class depends on a class from dependency injection. So how does Microsoft instantiate this properly? Well, they instantiate it by coming here and saying, oh, I'm going to need a class instance first. So they go out to the logger and say, hey, let's instantiate you first, and then come back and insert that here and instantiate demo logic. And then they have that instance set up. So the system takes care of that chain of dependencies necessary. So it handles all that for us. Now, if you have a class library, you can use dependency injection, but that will come from your user interface project, the actual dependency injection. So you will set up dependency injection in your UI project and hand out the dependencies as needed to your class library. It's a very good way of doing things, because that way your class library doesn't have any hard dependencies. It just has the ability to ask for what it needs, like this, and then your central dependency injection system in your user interface project will hand down those dependencies as needed. Now, some people ask the question, yeah, Tim, what if I have a model? Where is that going here? How do you put models in here? And the answer is you don't, because models are something different. They are, they're not dependencies. They're just data structures, essentially. And so you don't put models into your dependency injection. Don't try to. There's wacky ways you can try to put them in. Just don't do it. So, for example, when I use Dapper for creating a connection between SQL and C# very easily, and I say, hey, here's the model name. Go create one instance of that model per row of data coming back. It's going to new up that model. It's going to create a new instance of that model. It's going to instantiate it. So yeah, that's going to create a bunch of instances of my model. That's okay. It's not what dependency injection is designed for, because it's not a dependency and it doesn't have dependencies, which is why you probably shouldn't mix your models with your logic, because then you possibly could have dependencies, in which case you'd have a messy setup. Also, we don't pass the dependency injection system around to our classes. We could technically do that and then just ask for the dependencies inside there. Don't do that. Just ask for what you need. So in this case, I need a logger. Don't ask for the dependency injection container and then create a logger. Just ask for a logger. All right. That way you're not creating tight coupling anywhere. So I think that's the big overview. Again, I have a full course. There's a lot more detail on this if you really need to have more information. But I thought this would be good to show you how the dependency injection system worked, so that even without that course, you can get the job done with your projects and use them knowing what you're doing, not just kind of blindly adding things here and hoping it works. All right. So that's dependency injection. If you have comments, thoughts, questions, leave them down below in the comments. I'd love to hear them. Also, if you have suggestions for future content, for example, putting dependency injection in a WPF app, sure, or a console app, sure. We can think about doing that. Go to the suggestions.iamtimcorey.com site, add that suggestion or upvote one that's there. I use that site a lot to determine future content of 10-minute trainings, of full training, of dev question videos, and also full courses. So definitely let me know what you're thinking, and hopefully others will also be wanting that same thing, and we can potentially see that in a future course. Okay, so with that, thanks for watching. As always, I am Tim Corey.